Hello viewers on YouTube. In this video tutorial, we are going to focus on mean deviation. So it is important for you to understand what the deviations helps us to do. The deviation tells us the difference between the observed values and that of the expected value. However, the good thing about it is that it tells us the mistake that might have been made while determining the expected value. For sample mean, the deviation is often referred to as an error, while for a population mean, the deviation is often referred to as residuals. So that's just some basic things you need to understand. But more important, how do we find it? Let's look into that. Let's begin with the formula that helps us to find the mean deviation of both ungrouped and grouped data. So let's begin with that of ungrouped data. The mean deviation, which is often written for short as MD, is equal to the summation of the deviation, which is often referred to as lowercase d, then divided by the summation of the frequency. But since it is ungrouped data, we're just going to assume it is n, as that's the total sum of the distribution. Perfect. Now for grouped data, the mean deviation MD, should I use different color for that? I think you should be able to identify it, is equal to the summation of the deviation. Typically, it should be the absolute value. Okay, absolute value means get rid of any value that has negative. Assume it is positive. Okay, you get rid of the negative. So in this case, it is the summation of the frequency times the absolute value of d, then divided by the summation of f. Okay, let me do it again. The summation is not really that clear enough. Okay, the summation of f. So these are the two formulas we'll be considering using depending on the distribution we are dealing with. So let's begin with example number 1. Consider the distribution on the board. As you can clearly see, this distribution is an ungrouped data, as there is no class interval and there is no frequencies, and in fact it's not being grouped using a frequency distribution table. So this clearly shows that it's an ungrouped data. Okay. Now, first and first, I would recommend we use a frequency distribution table to have everything being fixed properly and to have our work done in a very neat way. So let's construct a frequency distribution table. So the first column will be for our mark, the second one will be for the frequency, the third one will be for the frequency times mark, yes, fx. So we just find the mean, that's all. So I'm going to represent the mark with x, frequency with f, we have fx. Now we have the deviation. The deviation, for those that might be hearing it for the first time, but perhaps some might have been familiar with it, it simply equals to the distribution individually minus the mean x bar. Okay, perfect. So then we find the absolute value. Okay, so that's it. So these are just the quantities you need to solve for the mean deviation whenever you're dealing with an ungrouped data. Alright, so now let's begin. So let me go this. So let's arrange, since we are using a frequency distribution table, we have to arrange it in ascending order. So we have 3, 6, 9, 10, 12, and 14. So I'm going to increase this. So you notice that all this distribution just shows up once. Okay, just one at a time, just one. So fx will still gives us the same result: 3, 6, 9, 10, 12, 14. You might be wondering, what is fx? It means the frequency times the mark. Just multiply them, and that's it. Now, to find x bar, what formula helps us to do that? Since the distribution is an ungrouped data, as you can clearly see, it's a population. As you can see, given the numbers of stuff of the distribution. So x bar, we're going to write that at this top will be equals. So the formula is such that simply the summation. Wow, why am I writing the summation? Sum of what? This summation of the frequency times mark, then divided by the summation of f. Well, in this aspect, as we are right now, we have actually grouped it, so we're using this formula. Okay, so x bar is indeed equals to, so let's add this up, 3 plus 6, 9, plus 9, 18, plus 10, 28, plus 12, 40, plus 14, 54. Okay, so we have 54 divided by, what about the summation of f, right? Notice that we just have 6 distribution. There are 6 in number, that's just 6 divided by 6. So what exactly is 54 divided by 6? Notice that that will be equals to 9. So that's our x bar. So the goal now is to be subtracting 9 from each of these marks respectively, and in all cases we should be recording our result right in this column. Perfect. So 3 minus 9 gives us negative 6. 6 minus 9, considering the second row, 6 minus 9 gives us negative 3. 9 minus 9 gives us 0. Perfect. 10 minus 9 gives us 1. 12 minus 9 gives us 3. And 14 minus 9 gives us 5. That's it. So we have the fourth column to be fixed properly. Now onto the absolute value. Absolute value means wherever you see negative, you convert it to positive. You assume it's a positive. So the absolute value of negative 6 is simply 6. However, keep that in mind, that applies to numbers. Notice that the absolute value of minus 3 is equal to 3. And absolute value of 3 is equal to 3. If what we are having within the absolute symbol is not a number or a constant, but a variable, the result won't be equal to x, but instead plus or minus x. Okay, keep that in mind. Absolute value is used to eradicate negativity. So the absolute value of minus 3 gives us 3. Absolute value of 0 is still 0. For 1 is 1. For 3 is 3. For 5 is 5. And then we have everything we need. So we really don't need the x bar anymore. We can get rid of it. Oops. So now the MD. So MD, we said earlier, since it is an ungrouped data, is equal to the summation of absolute value of D divided by N, which is actually the summation of F. Okay. Now, if we do FD, fine, you have actually grouped the distribution, your mark will be considered perfect. You understand? Because that's perfect. But you can see the distribution is such that the frequency is just 1, 1. They repeat themselves just once, not more than once. So these formulas can still be applicable. In fact, it's recommended. Okay, as long as there's no class interval or showing that this distribution is a group data, then don't use that second formula we discussed earlier at the beginning of the video. So therefore, MD becomes, so the summation of D, let's add this up, absolute value of D. So 6 plus 3 is 9, plus 0 is still 9, plus 1 is 10, plus 3 is 13, plus 5 gives us 18. And N, we still got that to be 6. Perfect. So MD becomes 18 by 6. And therefore, we have 3. Or 6 in 18 gives us 3. And that is the mean deviation. And that tells us the residual of the expected value. And that's how to easily find the mean deviation of an ungrouped data. Now, what about group data? What if the data are grouped? What will happen? How can we find the mean deviation? Let's put that into practice. Consider the frequency distribution tally table. Find the mean deviation of the distribution. So as you can clearly see, this distribution is a group data as there is class interval. Within this class, we have many values. You understand? So therefore, it's a group data as ranges values are embedded within a class interval. So first and foremost, for a group data is to find the class mark. To find a class mark for a group data, the goal is to have these two values respectively and be dividing them by 2. that provide a class mark. Keep in mind, this is called upper limit and this is called lower limit. Keep that in mind. Okay. Now, 0 plus 4 gives us 4. When we divide it by 2, we have 2. 5 plus 9 gives us 14. Dividing by 2 results in 7. 10 plus 14 gives us 24. Divided by 2 gives us 12. 15 plus 19 gives us 34. Divided by 2 gives us 17. And 20 plus 24 gives us 44. And when we divide it by 2, we have 22. And therefore, we have the column being fixed. After that, we can find fx, the frequency times the mark. So 3 times 2 gives us 6. 6 times 7 gives us 42. 8 times 12 gives us 96. And 4 times 17 gives us 68. And finally, 3 times 22 gives us 66. And therefore, we have the fx column to be fixed properly as well. So now, at this point, the goal is to find the mean. So how do we find the mean? As you can clearly see that this is a group data, so the mean is going to be the summation of fx divided by the summation of f. So what is the sum of the frequency? 3 plus 6 is 9, 9 plus 8 is 17, 17 plus 4 is 21, 21 plus 3 is 24. So we got 24 for that. Now the goal now is to find the summation of fx. What would that be? To do that, I'm going to use my calculator for that. So 6 plus 42 plus 96 plus 68 plus 66. So I got 278. So eventually, the x bar results in 278 divided by 24. So the answer divided by 24. So I got 11.58 approximately. So this is x bar. So now we can find x minus x bar, which results or which gives the deviation. Perfect. Don't forget x bar is 11.58. So x bar equals 11.58. So now let's proceed. So for the first mark, which is 6, which is 2. So 2 minus 11.58, that gives us negative 9.58. Then the next mark, how have I selected that? The next mark is 7. 7 minus 11.58, 7 minus 11.58, minus 4.58. So the next one is 12. 12 minus 11.58, we should got 0.58 or 0.42. Yeah, 0.42. Now on to 17. 17 minus 11.58 gives us 5.42. And the last one, 22. 22 minus 11.58, that gives us 10.42. So that's it. The goal is just to find the absolute value now. So let's find the absolute value of D. So the absolute value of this is 9.58, 4.58, 0.42, 5.42, and 10.42. Now the frequency times the absolute value. So the first frequency is 3. So 3 times 9.58. So I got, let me use different color. 2.28.74. So the second one, 6 times 4.58. That gives us 27.48. And the third one is 8. The frequency is 8. This is again, okay? 8 times 0.42, so got 3.36. And the fourth one, the frequency is 4, so got 4 times 5.42, that gives us 21.68. The last one, the frequency is 3, so 3 times 10.42. 3 times 10.42, so I got 31.26. Now the goal is to add them up. Don't forget, MD is equals to a summation of f times the absolute value of the deviation divided by the summation of f. So let's add that up. So 31.26, I'm starting from the down, plus 21.68 plus 3.36 plus 27.48 plus 28.74. So got 112.52. So therefore the mean deviation will be 112.52 all divided by 24, and we'll end up with 4.68 approximately. So that is the mean deviation, or we can set 4.69. Okay. And that's how to find the mean deviation of both group and ungrouped data. I hope you find this helpful and understandable. Thanks for watching. See you in the next video. Bye for now. However, this is your exercise. Feel free to share your solution via the comment section below. Consider the frequency distribution tally table on the board, find the mean deviation, and share your solution with me. Thank you. Bye for now once again.